All right, it looks like our folks jumping on has slowed down. So we'll go ahead and get started. Thank you everybody for joining us tonight for the Piney Run Reservoir public meeting. Um, my name is Kelly Stoll and I am with AECOM and I'll be facilitating tonight's meeting. Some of my colleagues have been working on the study, so they'll be with you along with Chris Hine from the county to give you a presentation. But before we do that, I want to cover a couple housekeeping items. Everyone is on mute for right now. We would like to hear from you though. So following the presentation, we are going to go ahead and if you use the raise hand function at the bottom of your screen, please click on that and put up your hand and we'll get to you following the presentation. I see someone has already asked a question in the Q&A box. We will run through those as well. If you're not comfortable speaking on mic. Let's see if we have anybody. I don't see anybody on the phone right now, but if we do have anyone, we'll give them an opportunity to ask any questions as well. And we will answer as many questions as possible tonight, but keep in mind that your questions either through Q&A, and I know some folks have sent in questions via email prior to the meeting. We will be putting together a Q&A document and covering those, and they will be posted up on the website, which will provide you with the address at the end of the presentation. And a final reminder that the meeting is being recorded. So with that, I will turn it over to Chris Hine from Carroll County. Chris?
Yes, thank you. Good evening, everybody. I'm Chris Hine. I'm the Bureau Chief for the Bureau of Resource Management, and I've been the lead staff person from the county on this project. Appreciate everybody taking your time out to attend the meeting. I apologize for the virtual format of the meeting. Would much prefer to meet everybody in person and to hold these discussions in person. And with the nice weather, logistics would have worked out. We could have had it out on the dam itself, but things are as they are. So we will make do with this virtual environment. So the intent of the meeting today is to present information about the project and to answer any questions that you may have. So Jeff Blossom and I will go through the presentation and provide you with the information. And then at the end, we'll be more than happy to answer any questions that you have. So with that, I'm going to get started. So we're here to talk about Piney Run Reservoir. And we have an image up there of the aerial photo of the area. The reservoir itself was constructed in 1974, and it had three primary uses, principal uses for why it was constructed. And those are flood control, water supply, and recreation. So next slide, please. So the reservoir itself is held back by Piney Run Dam. And the dam is 73 feet tall and 600 feet long. It's the largest dam that is owned and operated by Carroll County. The reservoir behind it is approximately 290 acres of water. The maximum depth is 54 feet. And I don't think you can really quite see it in the image, but there's a buoy, a red buoy that is floating right next to the dam. That buoy is actually tethered to the lake drain, and that's the point of the deepest water. That's where it's 54 feet deep. And the overall capacity of the reservoir is about 1.7 billion gallons. Next slide, please. So as we're talking about the dam and the reservoir, I wanted to talk about some of the key terminology so everybody is on the same page and knows exactly what it is that we're talking about. Obviously, the dam is the most important feature that we're talking about here. The picture in the upper left corner shows a picture of the dam looking along it with the reservoir off to the left. The water level, the permanent water level in the reservoir is maintained by the principal spillway, which is made up of a riser structure. It's a concrete structure. And it's pictured in the upper right corner. So that concrete structure has openings on the side, and the elevation of those openings is what controls the water level in the reservoir. So the water flows out through those openings, drops down to a pipe. It's a 3-foot diameter pipe that runs through the dam and runs out to Piney Run. So that's what we call the principal spillway. Now in the left side of the screen, the auxiliary spillway, it's also sometimes referred to as the emergency spillway, is another way for water to exit out from the reservoir. So as you can imagine, we have stream flow constantly coming into the reservoir. If we have a large storm event, that we have a lot of water then coming in and the reservoir fills up more. And that principal spillway is trying to control the amount of water that goes out. If it's such a large storm that it's greater than what that principal spillway can handle, then water would go out the auxiliary spillway. And that's a safety measure. The idea is for the water to be able to get around the dam without it going over the dam, which would be an issue. So the auxiliary spillway is pictured in the lower left corner. It basically looks like a big open field, but it's actually a wide, over 200-foot wide channel that allows water out of the reservoir. So then the last component to talk about is for water supply. So the picture in the lower right, which if you've been out to the dam, it's the concrete structure that has a shed on top of it and the walkway, the catwalk out to it. That structure is actually for water supply. And it has openings at different depths going down into the reservoir. And there are valves in that shed that can be opened and closed to withdraw water from different depths. It currently has a pipe that runs from that through the dam and goes out. Currently, it connects into the stream, but it could be connected to a raw water line to then withdraw water from the reservoir. So those are the basic components of the dam and the reservoir, just so everybody's on the same page with terminology. Next slide, please. So through this slide in, just because I find it interesting, just to put in reference the magnitude of the structures that we're dealing with. The concrete structure on the right, this is from during construction around 1973, 74. The concrete structure that's in the foreground is the riser structure that I talked about. And so you can picture that's the top of it is what you see over on the upper right. Yes. And so water flows in the top there and then drops down and flows through the dam. A picture, the dam is not in this picture. It was then constructed to the left of those concrete structures and the reservoir is to the right. And then the structure in the background is the water supply structure. So, right, next slide, please. So Piney Run Dam is classified by MDE, Maryland Department of the Environment, Dam Safety, as a high hazard dam. It's the only high hazard dam that the county owns. And the reason why it's classified as high hazard is you can imagine that we've got 54 feet of water stacked up behind the dam right now. During a large storm, that water level could rise all the way to the top of the dam or higher. So we could have over 70 feet of water stacked up behind the dam. If something catastrophic were to happen to the dam and the dam were to breach and release that wave of water, it would flow down the stream channel. And you can see in the background of the aerial photo there, we have Maryland 32 in the background. That flood wave that starts off at over 70 feet tall, when it hits Maryland 32 would still be 30 to 40 feet tall. So you can imagine that would be a catastrophic event. And that flood wave would continue downstream and would impact over 240 properties and 40 other road crossings. So there is a potential, there is a risk for catastrophic damage and loss of life if the dam were to fail. So to offset that, there are some criteria that we have to follow. And one of those is very high standards for the operations and maintenance of the dam. And the second is that the design of the dam and the infrastructure, it must safely pass the most severe storm that's predictable. So next slide, please. So one thing that I want to make sure that everybody who's listening understands and takes away from this is that from an operation and maintenance perspective, there are not any issues out at Piney Run Dam. This is not, we're not doing this project because there's a structural issue or a critical issue that needs to be addressed right away. The dam is inspected every year by county staff, MDE state staff, and NRCS engineers to make sure that it's in good condition and well maintained. And we just performed our last inspection this past November, and we've just received the annual report from MDE, and we get excellent marks across the board with how it's maintained and the condition of the dam. So this is not an issue that we're trying to address some deficiency in how the dam has been operated. So next slide, please. So the reason why we're doing this study is because of an MDE compliance question. So as I mentioned, one of the things that we have to look at is can the dam infrastructure and the spillway safely pass that design storm, that worst possible imaginable storm? And so it's really a question of the spillway capacity. Is this spillway wide enough in order to handle the flow for that worst imaginable storm? The other question, it relates to the erodibility of the spillway. So if we have a storm that's large enough that water is going out that spillway, that earthen spillway, and it starts eroding, it could erode back and fail the dam and the reservoir. And so MDE a couple of years ago posed those two questions, and they directed us that we have to perform a study and determine if their concerns are valid or not. If they are valid, then we're required to mitigate those issues by 2027. And so that was the impetus for all of this work. So we hired AECOM, and so their work is being funded out of a grant from NRCS, who originally constructed the dam. And they have been working for the past just over a year on all of this analysis to determine whether those questions are valid, whether there are issues. Plus, they've done a comprehensive inspection of the dam, et cetera. But I'm going to turn it over to Jeff Bloss from AECOM, and he's going to talk about the work that they've done and the results that they've come up with.
Thank you, Chris. Good evening, ladies and gentlemen. Thanks for taking the time this evening to join and participate in this what I think is a very important public meeting. I'm going to talk a little bit first about the work we did, and then go into the alternatives that came from it, and then hand it back to Chris to talk about kind of some of the evaluations, pros and cons of those alternatives. So as Chris mentioned, AECOM was brought on to do a very detailed investigation of the dam, and then to look at MDE's concerns and determine if those concerns were valid, develop alternatives for addressing them, along with the look at water supply, which we've all heard about. So the initial investigations we did covered detailed inspections of the dam. In addition to the visual inspections done every year, we did a second visual inspection. We also inspected all of the conduits that run through the dam. So there's the two that Chris mentioned, one for the principal spillway and one for the water supply structure. And then there's also several drain pipes that drain internal water that's inside of the dam that drain it safely away. So we did camera inspections of those conduits in addition to the visual inspection of the dam and the spillway. We also performed a detailed hydrologic and hydraulic analysis of the watershed. So this is basically a study of how much water will run off out of the watershed and end up in the reservoir, and then how the dam and reservoir handle that water during various storm events. And then what happens when it's passed through the dam and goes downstream, including under those circumstances where we simulated catastrophic failure, so that we'd understand what the consequences would be downstream if a catastrophic failure were to occur. We also did a very thorough geotechnical analysis of the dam. We drilled 25 holes in not only the dam and the spillway, but also in the abutments of the dam, which are the locations where the dam meets the valley wall, the side slopes that are next to the dam. We took a number of samples, completed laboratory testing, and then ran some geotechnical analyses of modeling various aspects of the dam and the spillway. We also did what we call a bathymetric survey of the reservoir. So this is basically a survey of the reservoir bottom. It helped us determine how much water is in the reservoir, and then based on what we knew about the original volume of the reservoir, how much has been lost to sedimentation. And then we also looked upstream and tried to identify sources of sedimentation and estimated the annual sedimentation rates. The last thing we looked at was all the environmental, cultural, and archaeological aspects of the site, around the dam, looking at, things like wetlands, streams, locations of cultural features, historic features. So some of the artifacts that we recovered are shown in the lower right. And that doesn't include the foundation that we found downstream of the dam, a bit downstream of the spillway. Next slide, please. Thank you. There we go. So the first aspect that MDE wanted us to look at was the auxiliary spillway capacity. And so this deals with the spillway's ability to pass, as Chris mentioned, that worst case storm event. So we call that the probable maximum flood. And so this is a meteorological event that it varies by region. And so for this particular region of the country, we're talking about 39 inches of rain in 72 hours. So over 3 feet in 3 days, foot a day. You got to think of it like that. To give you people who are around in the mid 70s, this is over 2.5 times greater than what fell during Hurricane Eloise. And that's the largest storm that the dam has seen. Most people know that Hurricane Agnes occurred 3 years before, but that was before the dam was constructed. So a little over 2.5 times greater than Hurricane Eloise. So that probable maximum flood needs to be safely passed through the auxiliary spillway. And so what that means is that it needs to pass through the spillway without overtopping the dam. And so right now, it doesn't do that. That was one of the findings of our hydrologic and hydraulic analysis, was that the dam does not have the spillway capacity to pass that required design event. So we looked at different solutions for dealing with that. We looked at constructing a second spillway. We looked at just wholesale widening the first spillway until we could meet what we needed to. We looked at just raising the dam. What we came up with was the most efficient solution was a combination. Kelly, if you can click forward, please. Was a combination of widening the spillway and raising the dam a little bit. So basically the idea is that we would take some of the soil from the right side of the spillway and widen that spillway out to create more capacity for flow to flow through the spillway. And then we would put that on top of the dam and raise the dam up, which also helps to increase the capacity of the spillway to convey flow. Next slide, please. The second aspect that we needed to look at, from MDE at least, was the auxiliary spillway's potential for erodibility. The auxiliary spillway, through our geotechnical analysis, when we drilled into the ground and took soil and rock samples, we found that the auxiliary spillway was actually constructed on a combination of soil and what we would refer to as highly weathered rock, which means that rock that's not competent, it's not sturdy and strong and massive or big. It's starting to break up. It's starting to kind of turn into soil. So it can be pretty weak. And so that doesn't have a lot of resistance to erosion, especially under the kinds of the type of storm event we're talking about needing to design for. And so the concern here is that with all that soil and highly weathered material in the spillway, that when we got a big event and the spillway were to flow, that we could start to have erosion that started at the downstream end of the spillway, which if you're at the dam, you'll know that the downstream end is towards the woods. And then it would start down there and then work its way back up through the spillway and ultimately possibly end up in an uncontrolled release of the reservoir through the breached spillway. And you can see an example of that in this picture here that was a failure that occurred in Mississippi in 1983, where that exact event happened. It's the erosion started at the downstream end. It worked its way up through the course of the storm up to the upstream end, and the reservoir released through the breached spillway, and they lost the reservoir. So something obviously we don't want to happen. One of the other things that makes this particular site susceptible is that even though the spillway is pretty flat, where you can see it, where it's wide open, once you get to the woods, the slope gets really steep, and that's exactly where erosion can start. And if it starts there, it can start to work its way back. And so what we thought, we looked at a number of solutions, different types of ways of cutting it off with concrete walls and internal improvements and armoring the spillway, where we put down different types of protective material. And what we decided was that at the end of the day, the place we really need to protect is that downstream end to prevent the erosion from happening in the first place. And so the solution we came up with was a concrete armoring of the downstream end of the spillway, combined with some smaller, more minimally invasive solutions upstream to prevent any erosion that would happen in the middle from causing any problems. Next slide, please. So from MDE's perspective, as Chris said, I think that the deadline to deal with the MDE compliance component of this work, we talked about raising the dam and widening the spillway as a solution and armoring the downstream end of the spillway. That needs to be implemented by the end of 2027. And so for that piece of the work, the estimated costs are approximately $7.5 million, covering design, permitting, construction, all things in between. And the potential for NRCS participation is that they would fund 100% of the design, and then there's a 65-35 cost share with the county, where NRCS would pay for 65% of construction and the county would pay for the remaining 35%. And so that means, in real dollars, that means a potential for a $5 million NRCS grant. Next slide, please. So now I'll talk about the other aspect of this, which we were asked to look at, which was the potential for future water supply security. So we looked at what has been traditionally engineered to be determined as the safe yield of the reservoir, which is basically an assessment of how much water can be withdrawn from the reservoir on a daily basis without causing it to drop below a minimum required pool elevation or pool level. And so based on that and the understanding that there is a certain amount of volume allocated for water supply, it's about 38% of the total reservoir volume all the way up to the top of the dam. We looked at that. We looked at that against the sediment that we found accumulated in the reservoir. And in the course of our study, we found that there has been approximately 725 acre feet of sediment that's accumulated in the reservoir. And so to put that into kind of a photographic perspective, think of a football field that's 725 feet high. And that's how much sediment has accumulated over the 45-year life of the reservoir. And those of you who live or recreate up at the upper ends of the lake or in some of the coves have probably seen evidence of that in terms of very shallow water depths or even exposed sediment. So what that does is it takes away from the available volume of water to be used for recreation, to be used for water supply, et cetera. And so that's the first part that we have to deal with is either we remove the sediment or we somehow offset the sediment. Removing the sediment because of it's that volume. And so again, in another way, 725 acre feet is about 1 million cubic yards of sediment. It's a lot of sediment. Sediment is very difficult to, not necessarily to remove, but to then transport safely without spilling it and then finding a place to put it. That creates a very cost prohibitive scenario where removing the sediment could potentially cost more than all of the other work combined. So we looked at alternatives to just simply removing the sediment. And so one of the alternatives that arose was the possibility of offsetting that loss in volume by raising the pool so that it would be 2.3 feet deeper than it is now. And so looking at that, there are obviously a number of impacts that are related to that. And so the first is that we would have to modify the two structures, the water supply structure and the principal spillway riser. We'd also have to construct a concrete structure across the spillway because everything is going to basically be lifted up. So the amount of the normal pool, so what you see every day, the reservoir level every day would be higher. And so if we got a large rain event, the amount that water would rise would be higher because it's going to have a higher starting point. So everything has to be lifted up. The dam crest would have to be raised, everything like that. So in addition to that, we also discovered that based on the design criteria at the time, the principal spillway riser would need to be modified. It would need to be reinforced. It's not designed to handle the additional forces that would be imposed by that deeper pool. And so the riser structure would need to be reinforced from top to bottom to make it structurally sound. In addition, The recreational area would have to be modified, not only because the pool would be higher, so your boat ramps would be a little bit shorter and your docks would be starting to get inundated, but the docks would also have to be modified and the ramps modified to accommodate the idea that with water supply, your pool level would fluctuate up and down. And so we would have to modify the recreational area to address that so that it could still be used under, all of those circumstances. And the last one is kind of getting back to that riser structure. Because we'd have to reinforce it all the way top to bottom. At this planning stage, one of the ways that we can do that safely is to drain the reservoir. There are other ways, they have different costs associated with them, but one of the ways we were looking at is draining the reservoir for construction. Not construction of the whole job, but certainly for construction of these riser modifications to make sure that it's done safely. Next slide, please. So what does this look like from a cost perspective? The total project costs, you're talking about an additional $8 million in design, permitting, construction costs that could be funded by NRCS. So that would now make the total dollar value $15.5 million. NRCS would pick up 65% of that. So we're talking about $10 million. Plus there'd be an additional $5.5 million county investment that's not reimbursable. So a total of $21 million in the total project cost with a potential for $10 million in NRCS grant funding. Next slide, please. Now I'll hand it back to Chris to discuss kind of how the alternatives shake out relative to each other.
All right, thanks, Jeff. So in order to convey these alternatives and these choices to the county commissioners, we've boiled it down to three choices, three alternatives. And we have a graph that's on the left that graphs out risk on the bottom and reward on the left to kind of compare them as far as the risk and reward of the different alternatives. So the first alternative we call alternative zero. And from a staff perspective, this is not a popular alternative, but it's one that we have to present to the county commissioners as it is an option. And that is to basically say, we're not going to do anything. So it's the non-compliance option. The reward, the positive to that is that there's basically no investment of capital and resources by the county. So the estimated budget is zero. The downside of this though, the risk, is that we're talking about a public safety issue. We're talking about a compliance issue. Maryland Department of the Environment has the legal authority to enforce these requirements. And so MDE could basically then step in and perform the work and then charge the county for the work that's performed on our property. So one way or another, these compliance issues need to be addressed. And if we go with the non-compliance route, then we would have no control over the costs. MDE would basically do whatever they felt was appropriate, including they could choose to remove the dam, because if you remove the dam, you remove the hazard. And that's not an alternative that anybody wants. We do not want the dam removed. So while this is an alternative that we have to present to the commissioners as an option for their consideration, we certainly do not recommend this alternative, but it's one to consider. Next slide, please. So alternative one is basically compliance only. So this is that estimated $7.5 million. The reward is that it's the lower county investment. It addresses all of the compliance issues. And what's very important to note is that choosing alternative one does not preclude future water supply use. By going down alternative one, we are not going down a path that's non-recoverable. So if we chose to in the future, we could still implement water supply out of the reservoir, and we would not have wasted significant money by going down a path that we should have gone a different way. So that's very important to note. The other benefits are that there's the potential for NRCS to cost share, so that's a big positive. And there's also anticipated minimum impacts to the reservoir during construction. And I just want to be clear about that. We are in a planning stage here as far as the improvements that we're looking to make. Looking at those improvements, we feel that those improvements can be made without affecting the water level in the reservoir during construction. That being said, when we get into the design process, Who knows what we'll come up with, but I think it's very unlikely that we have to do anything that affects the reservoir during construction of these alternatives. The downside to this alternative is that there's no potential then for NRCS cost sharing for future water supply. Right now is our opportunity. If the county commissioners decide that they want to go down that path of implementing water supply, now is the time to start down that path, because there's the potential for getting additional funding from NRCS of another 7.5 million, or 5 million, whatever, millions of dollars to assist us with going down that path. So that's the risk of choosing alternative one, is that we will lose that opportunity for federal funding. So next slide, please. So alternative two then is both compliance and water supply preparation. So in this budget is somewhere between $15.5 and $21 million. The benefit is that there's the potential for NRCS to cost share a good portion of that. As with alternative one, it addresses compliance issues related to public safety. And the big benefit here is that it's preparing us for water supply security. So it takes us down that pathway of having Piney Run as a water supply. Now, I want everybody to be very clear. At the end of this, say hypothetically, if the commissioners chose alternative two, that does not mean that at the end of this construction project, we have water going to people's taps out at Piney Run. This is just the first step. There are multiple steps that would have to go through. Primarily, we have to take into consideration permitting. So there's appropriations of the water supply. There's permitting related to it. And then there's additional infrastructure that would need to be constructed to treat the water, to convey it, and so on. So those estimates, they were not, that analysis was not part of this study because it's off the site of the reservoir. Estimates from our Department of Public Works is that those could be an additional $10 to $40 million. So just so it's clear, selecting this alternative does not implement water supply at the reservoir when we're done. It starts us down that path, which then we, excuse me, we'd also need the permitting, appropriations, and additional infrastructure. So just so that's clear. So then the downside, the risk of this alternative, one is that it's a higher county investment. A big concern, obviously, I'm sure for many of you, is that it may require the full draining of the reservoir for construction. Now, as I mentioned, we're in the planning stage here. We have not designed how this construction would occur. We obviously would look at alternatives for doing things like maintaining some level of water in the reservoir for fish and other aquatic life. That's certainly an alternative that we would look at and options that we would look at, but we have to balance the cost versus the benefits there. But we are not in that stage yet. We have not gotten to design yet. So the worst case scenario, which we want everybody to be prepared for, is that there's the potential that if we went down this alternative that we would have to fully drain the reservoir. The other potential negatives or risks is that there's the potential loss of revenue during construction to the park. And also, as I mentioned, that full implementation of the water supply would require additional investments beyond the 21 million. So next slide, please. So that's basically our presentation. This is the exact same presentation that we gave to the commissioners on February 25th. This is the second of the public meetings today. So looking forward, and we have tentative dates for some of the other action items. On March 18th, I'll be going before the county commissioners to request to go to a public hearing. So that'll be a quick 5-minute just request for permission to go to public hearing. Tentatively, the public hearing is scheduled for March 25th. At that point, that would be the opportunity for anybody who would be interested in weighing in open session to the commissioners. That would certainly be an opportunity for conveying your opinions on how to proceed. And then typically what happens is that the commissioners leave the public record open for a week to 10 days, and we're tentatively scheduled for April 6th to go back before them for them to deliberate and to make a decision. Once the decision is made, then Jeff and the rest of the folks at AECOM have a lot of work to do with further documentation and so on, working with NRCS. There are a lot of reviews of reports and so on that need to happen between now and September, October timeframe, and that'll complete the watershed study. And then our next phase would be taking that alternative, putting together a scope, and applying to NRCS for grant funding for the design phase of the project. Then looking long-term, we anticipate that the design and permitting would most likely take the better part of 2 years. And then we would be looking at construction probably in the 2025, 2026 timeframe, so that we're complete with everything by 2027 when MDE has requested that we can be done. So that's a general overview of the schedule. At this point, I'll turn it back over to Kelly to moderate for questions and so on. What I would point out is that I am not the decision maker here. The county commissioners will make the decisions. Love to hear your opinions and so on. We are going to hear your opinions and make note of them. This is being recorded, and so the commissioners can certainly rewatch it. But what I would suggest is if you convey your opinions and so on via email. That way you're not, it's not our interpretation or our synopsis of your feelings about this, that you can either directly email piney-run-study@carrollcountymd.gov, or if you go to our website, there's a button there that you can click on that basically fires up your email and sends it to the same address. So that way the information, all your comments and questions and so on, we're going to compile those into a packet to give to the commissioners that they can review and for making their decision. So with that, happy to turn it over and answer any questions that you have.
Thanks, Chris. As I mentioned, everyone is muted still. If you would like to ask a question, we'd be happy to talk with you directly. So use the raise hand function at the bottom of your screen. If you have a question, again, as Chris mentioned, email piney-run-study@carrollcountymd.gov, and the website has an email link, and the website is right here at the bottom. We will take the questions and answers that we've been getting via email and in this meeting to compile a Q&A document that'll be posted on the website. We can put that up there. We do want to arm you with information for you know, the comment period that will be open that Chris mentioned. So with that, I'm going to go ahead and take a question from the folks who had used that Q&A box during the presentation. And the first one I will ask is, Chris, is there a location where somebody can review the documents when the reservoir was first built back in '74?
The documents when the reservoir was first built. So I guess I would ask which documents they're looking for. So there is the original watershed study. This is actually the second watershed study that's being done for the reservoir. So there was the original watershed study done in 1968. We have that, which I'm happy to share that. I don't believe we have that posted on the website, but happy to share that. And then we have the original construction drawings. And those I know we don't have posted, but those are also available if anybody wanted to look at. So beyond that, I'd say make a specific request for a specific document, and if we've got it, happy to provide it.
Okay. Speaking of requests for things, folks are wondering if the slides will be available on the website.
Yes, we can post those on the website.
Okay. And just note that, as I mentioned, this is being recorded, and the recordings will live on the Carroll County social media pages, YouTube channel.
Yes.
Chris mentioned earlier. in our earlier meeting, so wanted to point that out for folks as well. Let's see. What is the environmental impact of draining the reservoir? Has there been an impact assessment as part of the alternative 2?
No, there has not. So there is an environmental study that is part of the watershed study in general. Once an alternative has been selected and we know what direction we're going to go forward with, the design permitting / phase would evaluate whether enough environmental study has been performed as part of the watershed study, or if it's alternative 2, if additional analysis needs to be done. And so we're kind of in a period of flux here, in that we first have to determine which alternative we're going to proceed with. And then once the commissioners pick that alternative, that'll drive the design and permitting and whether more analysis beyond what's already been done is necessary.
We have some multi-part questions here. The first of that question is, are there absolutely no other options to avoid draining the lake and still get the benefit of using the lake as a water supply?
So as I pointed out, the alternative 1, which is just compliance, does not preclude water supply in the future, okay? And water supply, the reservoir could be used for water supply without adjusting the normal pool. However, it would not provide as much water supply as we're looking to achieve, if that makes sense. So there is a yield that the reservoir is supposed to have, a certain amount of water that could be withdrawn for water supply. Right now, with the water level where it is, we cannot achieve that yield because of the sediment. So that's why we're looking to potentially raise the normal pool to get them to achieve that yield. So there is the potential that in the future, if water supply could be implemented without that rise. However, we would not get the yield that we require. So yes, there are alternatives to be looked at and so on, but we have boiled it down to basically those 2 choices of compliance only, or what we feel is the method of moving forward with going down the route of water supply, meeting the needs of the county.
Another part of that question is, would it be possible to draw water from the lake at the level that it is now, even if there were a lack of temperature, quality, et cetera, that would be preferred?
Right. And that's basically what I was saying, is that, yes, water could be withdrawn from the lake as it is now. However, we would not get the yield that we require. And those other issues of temperature, water quality, and so on would factor into what our safe yield is, which is why that option of raising the pool by 2.3 feet is the one that we're looking at.
Jeff, this might be a question for you. Is it at all possible to budget the amount of sediment that comes out, perhaps over a period of years, to spread, I think, in an effort to spread the cost? Or is it one of those things that just needs to be done all at one fell swoop?
I think that's more of maybe a question for Chris, but I would comment that a kind of a prorated plan or something like that, where a certain amount is dealt with every year, would certainly be something that would need to be agreed upon with NRCS and with the state of Maryland and a lot of other entities. But I'll let Chris add on anything he wants to that.
Yeah, so I mean, the sediment is an issue that we need to look at, and there is a continued there's more sediment coming in every year, right? And so we'll be looking at projects in the watershed on how we can reduce that through stream restoration, stormwater management, and so on. Really, the sediment that's in the reservoir now already, it's a matter of cost. Like Jeff mentioned, we're looking at 1.2 million cubic yards of sediment. Dredging and transporting and so on, say you use a round number of $40 a cubic yard, we're talking $40 to $50 million to remove the sediment. And those are very, I'm just grabbing numbers. We haven't looked in depth at what those costs are. We just know that it's cost prohibitive.
With many of the properties surrounding the reservoir lower than the height of the dam, wouldn't the water flow on that property before it even crests the dam?
So as the reservoir would fill up during a large storm, yes, the water would rise and be on other properties. However, the direction it's going to flow is down valley, which is through the auxiliary spillway or over the dam as it is currently. So it would not flow out over those other properties, but it would raise to a level where it would be on those properties.
Okay. Since the reservoir has been in place, has there been an occasion where the water even came close to a height of being concerned of breaching the dam?
So as Jeff mentioned, the largest storm event that the reservoir and dam have experienced was during Hurricane Eloise in 1975. During that storm, water came up and into the spillway, into the auxiliary spillway, but did not actually flow through the spillway. We have firsthand description of that occurrence, and we have pictures of it. And my understanding is that there was a car tire track that a little bit of water ran down through that. But so that was the highest level that the reservoir has seen. So, but that being said, we have to design these reservoirs and these dams for the worst case scenario that could potentially happen. I tried to nail down Jeff earlier, but he dodged it. We often think in our line of business, a return period for a storm. So like a 100-year storm is something that statistically happens once every 100 years. And I asked, is there a return period that's been figured out for this maximum storm that we would have to look at? And there really isn't. But say, just for argument's sake, it's a 10,000-year storm. What that means is picture a roulette wheel with 10,000 numbers on it. And every year you spin that wheel. If it hits the number one, then we have that storm and we have an issue. So every year for the past almost 50 years, we've been spinning that wheel. It doesn't mean that this year it may not happen. It could happen this year, it could happen next year, it could happen 10 years from now, it could happen 100 years from now. But someday it will happen. And that's what we have to prepare for, is when that happens, that it meets those design criteria and it'll safely pass that storm and should not catastrophically fail. So that's why we're looking at this.
Chris, I would add that this type of event is not, this requirement is not unique to Piney Run. It's not unique to the state of Maryland. This is a nationwide, actually close to worldwide industry standard storm for dams that carry the potential hazard that Piney Run does. And even dams that are much smaller, that carry smaller potential hazards, are held to similar requirements. And the idea is just trying to be very, very careful with what we're dealing with here.
They go to the folks with their hands up, and excuse me if I mispronounce your name. Is it Rydia Deary? Go ahead, the floor is yours. Rydia? we will come back to her. And we'll go to Mr. Ignatius. Joe Ignatius?
Yes, I'm here.
Ah,
Can you hear me?
gotcha. Yes, we can hear you. Thank you.
Yeah, I want to thank you for the opportunity of sitting in on this tonight. It's very interesting. I live right around the corner from Piney Run, and it's definitely one of the best resources that our county has for recreation. And I take a personal interest in this. I worked for the Baltimore office of the Corps of Engineers for 40 years, and I participated in a lot of studies, just like what you're going through for Piney Run. So I'm very familiar,
Good.
you know, with you know, all the terminology, you know, the probable maximum flood. And I applaud, you know, the engineer from AECOM for not putting a return period on the PMF because, you know, we, you know, again, personally, I attended public meetings myself and everything, and they always asked, you know, what's, you know, they hear the 100-year flood, you know, number 2, and I always said, well, think of the Noah flood if you want to if you want to put it in any kind of a context. But real quick, I got a couple questions. When you routed the PMF through the reservoir, was the dam overtopped?
Jeff, you want to answer that?
Take myself off mute here. Yes, yeah, the dam currently does not safely pass the PMF. I think the overtopping depth under existing conditions is, if I recall correctly, let's say 3.5 feet or something like that.
Hey, Jeff, for us non-engineers, can you tell us what PMF is?
Probable maximum flood. So yeah, you'll hear those terms used interchangeably. PMF, probable maximum flood. Thank you for holding me to that.
Okay, I have one more quick question that dealing with the water supply aspect. Was there ever any was there an analysis performed to show that there is a need, whether it be current need or projected need in the future for this water supply, because the current you know, the current water supply that's available would not be sufficient for perceived future needs? You know, again, what I'm trying to get at is why would we even be looking at you know, water supply?
Sure, great question. So no, this is not we are not looking to implement Piney Run to address future need or future requirement because of a lack of water. We currently obtain water from Liberty Reservoir, and that currently meets all of our requirements. This is purely a water security and redundancy issue. So you're familiar, I'm sure, with if you have one source of water, which is such an important resource to everybody, if there is some sort of issue, say a drought or something like that, that puts that one single source in jeopardy, you want to have alternative sources so that it doesn't affect the citizens that rely on it. So this is purely a water security, redundancy, worst case scenario backup plan, so that we're not having a public meeting like this with angry citizens asking why we don't have water because we're in the middle of a drought.
Okay, well, thank you very much.
Sure.
Sorry, I was talking and on mute. We're going to go back to Rydia and see if she's back with us. And if I'm mispronouncing your name, please excuse me. Rydia? Okay. Well, we will try again. Now we're going to go to Sherry. Sherry, go ahead.
Hi, this is actually Matt Limecooler.
Okay.
And this issue seems to come up every 10 years. And I think in the past, it's been clouded with, I guess, concerns of impaired judgment by the decision makers, the commissioners. And so the question I have is trying to understand if this is not needed as a current water supply source. And with the timeline of the commissioners making a decision being so soon, almost feels rushed Do any of the commissioners or their family members have a conflict of interest that would create impaired judgment on their ability to make a decision on this issue?
Maybe you can help me with, I can't think of a conflict of interest. Maybe you can help me with what your thoughts are as an example.
So large campaign contributions from landowners looking to reduce barriers to dense development?
No. So
business interests in those development opportunities or with potential developer companies?
no, there's this has nothing to do with development. As I mentioned, this is purely about
interest, or no, this has nothing.
No, there are no conflicts of interest, and this has nothing to do with development. There is currently, so let me back up and give a little bit more background on how development and so on works. So when development is proposed, when a developer proposed, there's a process by which we evaluate whether existing infrastructure is capable of supporting that development. And that's called concurrency. And so everything from fire and EMS to water supply to wastewater capacity and so on are all evaluated to make sure that the area where development is proposed has the adequate facilities, adequate resources to support that development, right? So in the Freedom area, because water supply is one of those resources, it is any proposed development is checked for concurrency with water supply. And if there are thresholds based on capacity of water supply and so on. So currently, the Freedom area utilizes about 2 million gallons per day that come from the Liberty Reservoir. The capacity from the Liberty Reservoir is 6 million gallons per day. So there is currently not a lack of water. Water is not restricting development in the Freedom area. So bringing Piney Run online as a water supply is not to allow more development. It is purely a water security and water redundancy that if some sort of issue, say a drought or so on, occurred, that we lost capacity in Freedom from the Liberty Reservoir, that we would have a backup supply to help supplement that so it doesn't affect citizens of the county. Does that answer your question?
It mostly does, I guess. So maybe a different way or another way to state it would be, if pursued, would the new water source enable an expansion of development in Southern Carroll County that otherwise would be restricted or limited?
No, because as I said, current supply, current use is about 2 million gallons per day, and we have capacity for 6. And before you hit that adequate facilities threshold, I believe it's 85% of, yeah. So as long as we have not hit just under 5.4 million gallons per day, so you would need quite a bit more of usage before we even came close to water supply being a limiting factor to development.
Okay, so as we're talking about security, we're really looking at a 300% capacity of what's needed today, just from the existing sources.
Yes.
So we don't need the redundancy.
Thank you.
Sure.
Okay, I was talking to no one. Jeff, I think you, I'm sorry, Chris, I think you touched on this, but we had a question in the chat that it seems a lot of folks are concerned about development and, you know, the water supply and securing that has more to do with the ability to develop either commercial or high density dwellings, to use someone's word or term. I guess you touched on it, but from what you're saying, that is not, has nothing to do with why we would even look at the water supply issue.
No, and this is so, and hopefully everyone understands from the alternatives that we're presenting. Implementing water supply out of Piney Run is a long process. It could take a decade for us to get through the process before any drop of water can hit somebody's tap. It's a process where there's infrastructure that needs to be built at the reservoir. There's permitting, there's the appropriation of the water supply. There's, and then there's infrastructure to even get the water, the raw water to where it's treated and so on and so forth. That process could take more than a decade. We have a unique opportunity here with NRCS being involved, where we have the opportunity for federal funding in the tunes of millions of dollars to help us down that road of obtaining water security. And so it would be inappropriate, or I don't, whatever the word is, it's our responsibility as staff to present that to the commissioners for their decision. It would be negligent for us to miss this opportunity of these federal funds to help us down that pathway, so that the decision makers, the commissioners, can make a decision that's in the best interest of everybody.
We have a couple of folks asking about a timeline, if the draining of the reservoir were needed, what that timeline would be. And I know we talked about that in the meeting earlier today. So.
Yeah. So if we were to just pull the plug on the reservoir and drain the reservoir, that could be done. It would take about a month for the reservoir to drain. However, we do not want to do that. We would, as part of the design process, need to figure out what an appropriate drawdown rate would be for a multitude of issues. One is looking at the impacts downstream, and also making sure that we don't adversely affect the dam. A big earthen dam like this, you don't want to raise and lower the water very quickly, because you're talking about dry versus saturated soils and so on. So for a lot of technical reasons, we would not just want to, unless it was an emergency, just drain the reservoir, but it could be drained in a month. So we would determine through the design process what an appropriate drawdown time would be for the reservoir. And that could be, it might be 2 months, 3 months, so some sort of duration that would be figured out. The construction work that needs to happen at the base of the dam, again, we haven't done any of the design, so I can't really speak to an exact time frame, but with my experience with construction, I would say that it's at least a couple months, 3 months or so of construction work, at least. Then to fill the reservoir back up, once that work is done, that is wholly dependent on the weather. So how much rainfall we get. If we get a hurricane when we're ready to fill the reservoir back up, we'll fill it up real quick. If we're relying on just general stream flow, normal stream flow during the course of the year, it could take more than a year for it to fill back up. So, and there are other alternatives that I think I mentioned in this meeting also, is that, that we would be looking at. Are there alternatives where we could, say, sheet pile and hold back, say, 20 feet of the reservoir and not drain it all the way down? But we have to look at the cost benefit of that. If that's going to cost $100 million, we're not going to do that option. So for complete transparency and for this discussion, we have to talk about the worst case scenario. The worst case scenario would be a total drawdown of the reservoir. But obviously, I mean, we want to do what makes the most sense and is most cost effective and the least impact to the environment. So we will be looking at those other options. So what I would say is that if you're thinking in terms of a total construction timeframe from the reservoir where it is now, and then how long before through this whole process before it's back to where it is now, I would estimate 1 year or 2 years for that whole process. Obviously we would all hope that it would be less than that, but at this phase, we're just talking planning. That's 1 to 2 years is probably a good number to have in the back of your head. And then we can all be pleasantly surprised when it takes less time than that.
A quick question, and just to kind of put a finer point on that, is they want to know where will the draining be? Draining will happen Will it happen the reservoir as a whole, or will it, you know, in a specific spot or anything like that?
Sure. So think of the reservoir as a big bathtub, right? So, and we need to, and it's a bathtub that has a sloped bottom. So it's deeper right at the dam. And where we need to do work, unfortunately, is right at the dam. So if the work we had to do was up at the shallower end, then we could drain it just a little bit and do the work up there, and it would be easy. But unfortunately, where the work we believe that we have to do is at the deepest part. So the entire reservoir, if we were to drain the entire reservoir, the entire bathtub would have to be drained down. But again, as I mentioned, we would explore options for putting up a barrier around the area where we want to work. Now, I haven't talked to any construction industry folks and so on as to what's realistic for how high that barrier could be. I'm fairly certain, I don't think it's a stretch to say that a 54-foot high barrier would be feasible. So the reservoir would have to be drawn down some amount. Maybe we can draw it down 30 feet and we can have a 20-foot high cofferdam or sheet piling. Those are details that we would have to figure out through the design process and come up with the optimal solution.
I'm going to remind folks to use the Q&A function if you prefer to type in your question. We don't want to miss anything. We had a couple questions come in the chat. One is, have there been recent plantings in the proposed Gillis Falls site? And does this mean that Gillis Falls is off the table as a reservoir? And what would the cost of developing another site and heading towards water security?
Mm-hmm. Yeah, so you're absolutely right. Actually, we have done some plantings on some land in the Gillis Falls Reservoir area. And that was done with grant funding, and the funding agency, the Department of Natural Resources, asked us that question as to whether, okay, you're planting trees in an area that's designated as a future reservoir, right? And our response was that the likelihood of the Gillis Falls Reservoir being constructed anytime in the near future is very slim. There is, as I've indicated, there is not a water supply issue that's in this area that would require us to implement the Gillis Falls Reservoir anytime in the near future. And we also have existing resources such as Piney Run that are available to us that would be much less impactful, much less expensive, and are there to implement before we would explore the Gillis Falls Reservoir area. Now, that being said, can I say 100 years from now that Gillis Falls Reservoir isn't constructed? No. I don't know what the future will hold, but there are certainly no immediate plans for the Gillis Falls Reservoir.
We have several questions asking about environmental impacts. And I know that is part of the next step. So could you talk a little bit about the environmental impacts? And now as you talk, I'll kind of make sure that we hit everything.
Sure. Yeah, so as I mentioned earlier, as part of this watershed study, we are evaluating environmental impacts to work in general for both Alternative 1 and Alternative 2. Once the decision is made as to which alternative the commissioners would like to proceed with, if it's Alternative 2, we will then have to determine if additional environmental impacts will need to be evaluated. And that will be part of the permitting and the design process that we'll go through. We fully anticipate taking at least 2 years to go through that process of permitting and design of whatever requirements that we come up with. And that permitting process is going to include working with the Army Corps of Engineers, MDE, Wetlands and Waterways, MDE Dam Safety, all of those permitting agencies and Department of Natural Resources. So all of those agencies will look at what it is that we're proposing to do, what are the environmental impacts of what we would like to do, and then issuing a permit if they feel that it's appropriate. So that whole permitting process is something that would take place over a couple of years once we've determined what that alternative is that we're going to proceed with.
Go back to somebody on, I was going to say on the phone, but via voice, and ask Mr. Joshua Wampler. You'd like the floor?
Hello.
Hi
yes.
there.
Hello.
How you doing? So I guess my biggest question, we know the watershed is prone to sediment. And you're saying in order to make it a credible water source, you're going to have to dredge it out, and that's what, $40 million possible to do that, you're saying?
No. So, yeah. So let me just clarify that for you. So there's a significant amount of sediment that has flowed from the watershed into the reservoir. Removing that sediment would be cost prohibitive. So that's not an option that we're exploring. That potentially tens of millions of dollars just to remove the sediment. The other option, what we feel is a better option, is that rather than taking the sediment out, is to raise the normal pool, the water level where it normally sits, raise that by just over 2 feet. That would give us the water that we're looking for, and we would not have to remove the sediment. Does that make sense?
Or how does that calculate future sediment? I guess is what would that then leave us open for, if it's gained this much sediment in 50 years, say by the time the water source is even implemented, that's another, we have tons of these things kicked around in Carroll County, different quarries and such that they never use. So by the time, like you said, it's a lot of money. So by the time that comes into play, who's to say the sediment hasn't went up more, and now you got to raise it again to make it credible?
Yeah, so you're right. So we have, and AECOM has made some estimates as to how much sediment is coming into the reservoir every year. And Jeff, correct me if I'm wrong, but I think if I remember right, it's like 16 to 20 acre feet of sediment per year. Now to decrease that, to help offset that, we are working on and looking at additional projects in the watershed. And we actually have one under construction right now in the Woodside subdivision. There's a tributary that drains into Piney Run that has moved a lot of sediment over the years into the reservoir. And we're doing a stream restoration there to prevent that or reduce that amount of sediment that comes from that tributary. And so we would look at other projects. I'm sorry?
I've hunted a farm for 14 years up above Piney Run. I mean, it's on Piney Run, the stream, and that thing is constantly, just dropping 5-foot sections of bank off of it. So I can see that the sediment's not going to stop. So I guess you guys are doing something upstream to counteract all the sediment going in there then.
Yeah. And so, so the bureau, my bureau, is responsible for addressing those types of issues, sediment and nutrients and so on, from urban runoff. Soil Conservation District works with farmers such as yourself on practices that can help reduce the runoff from the streams that run through your farms. So I don't know if you work with Soil Conservation District, but I'm sure they'd be happy to talk with you and look at options that could help reduce that sediment load.
I guess that's my only question, is just the future sediment levels, and that's been already taken into consideration.
Yes, yep, that would absolutely be taken into consideration.
So
Right. Go ahead. Okay, well, we will move on. Thank you, sir. If you have something else, please raise your hand or pop a question into the Q&A section. I'm going to go ahead and take another couple of questions from the Q&A. What is the required yield of the water supply based upon?
So that goes back to the original watershed study and determining what the appropriate yield and I don't know, maybe Jeff, you can speak to the whole process and so on, but the reservoir was designed for a certain yield, I believe 3.5 MGD thereabouts, and yeah, so that's the yield that the reservoir was designed for, and whether we could appropriate that full 3.5 or whether it would be 2 MGD or something along those lines, that would be part of the permitting process and the appropriation process. But that's the order of magnitude that we would be looking to have that redundancy and water security.
Yeah, the original, the only thing I'll add is the original watershed study calculated what they call a safe yield, which is the amount that you can withdraw every day from the reservoir, and even in dry years, not have it drop below its allocated level in the reservoir. And that safe yield was calculated to be 3.5 million gallons per day. And it's been recalculated 2 or 3 times since then. I think the last was in 2009. And it's really never moved. I think the last run, it was like 3.65 million gallons per day, but not too much different. It's always been around that 3.5 million gallons per day level for this reservoir, for the volume of water that's allocated to water supply in the reservoir by the original watershed plan.
Let's see, we have a couple of questions about other sources of water in, rather than Piney Run. So we have one question about a series of large capacity wells on the grounds of the hospital. They were supposed to be used as a backup to Liberty instead of using Piney Run. Did that ever happen? And what's the status of those wells?
Yeah, so I can't speak to the current exact status, but I do know that our Department of Public Works is working with making those wells available. But I guess what has to be taken into consideration is the capacity of those wells. So we're talking about, and the term that we always use is million gallons per day. A well such as that might be 0.3, so thereabouts 300,000 gallons per day. So there is some capacity from those wells for water security and redundancy, but it doesn't come close to the capacity of Piney Run Reservoir. So that's why we're looking at that as well. But yes, because we don't have that redundancy, we are looking at other options. Like I said, Piney Run could take a decade before it could be brought online, even if we start the ball rolling now.
What other sources have been looked at within the county other than Piney Run?
Goodness, I'm afraid that you're out of my area of expertise. Okay. Maybe Jeff, you recall what some of the reports have indicated, but I mean, in this area, I know there's, I mean, obviously the Liberty Reservoir and the Freedom Plant. There's also a well, it's called the Fairhaven well, which is online. And then there are other wells considered and this, the Springfield wells and so on. So, I mean, like I said, so wells are always being considered and could be brought online for additional capacity, but they pale in comparison to the volume available at Piney Run.
I'll only add that like I mentioned, the last time the safe yield of Piney Run was recalculated was in 2009. I believe there was a look at that time at a number of other reservoir sites. One of the challenges in these times we live in now are that there's really not a lot of regulatory appetite for building new reservoirs that dam up streams and for obvious environmental reasons. And so any new reservoir that would be proposed is likely going to be what we call an offline reservoir, where basically you pump water out of the stream, you store it in the reservoir, and then you use it whenever you need to. There's a good example of one up in Bel Air that was constructed, I think it finished up 2 years ago, where they pump water out of Winters Run in Harford County, and they pump it into a big circular reservoir that they constructed, and then they use it for water supply. But the days of building dams across streams are basically over in terms of new dams. So I think some of the sites that were identified at that time are now basically off the table, just because they would not be permittable, or if they were permittable, it would be a decade or 2 decades of permitting, and a lot of work that may not justify the use of the reservoir.
Go ahead and we'll get back to our folks who would like to speak. Sherry Lime Cooler again. Go ahead.
Hi, thank you. I think that it's obvious that the safety issues addressed or pointed out by the MDE and the spill-off area, there's no doubt or much argument that that has to be done. The county needs to look at that being done as addressed in the, I believe, alternate 1. But as far as moving into alternate 2, it's been stated a couple of times that the water supply is purely being looked at as a redundant water or security issue. I don't see how that justifies the cost of that project or the potential damage to the lake environment, the habitats, the loss of the recreational facility, especially considering that we have a 300% capacity with our current source. And there's 45 billion gallons of water available in Liberty Reservoir versus 1.7 billion here in Piney. So that would have to be one heck of a drought in order for us to need this redundancy or this security. So I just don't see yet where there's any justification for alternate 2.
Yes, and you make very valid points, and that's why we're presenting all of this information and so on to the county commissioners. To they're the ones who make the decision which way to go with this. But yes, you have very valid points.
Okay. Is there anything being done to look at upstream development so that this location won't end up in a situation like Ellicott City or have other adverse impacts on the watershed?
Sure. So we are not looking, so that there are no proposed restrictions to development. This is not development driven, so just so that's clear. Unlike Ellicott City, which was developed over time, and some of it predates stormwater management regulations. Current stormwater management regulations, which have requirements for both water quality and water quantity management. All new development has to adhere to those state and local requirements. So that includes looking at the amount of runoff that comes from developed sites, so that we would not have an Ellicott City type situation. Hopefully I answered your question.
There's a question about pressure, well pressure, if the reservoir is drawn down. Will that affect well pressure?
Oh, well, you're getting outside of my area of expertise here. As part of the overall permitting process and design process, groundwater influence and the impacts of drawing down the reservoir would certainly be something that would be looked at.
The answer is we don't know yet, but that'll all be looked at
Yes.
if things move forward. Okay. Do you happen to know, Chris, when Carroll County's contract with the city expires, and if what the possibility of renewing or not renewing that would be.
I do not know what the contract negotiations or the terms of our contract are. I can certainly find out from our Department of Public Works. The chances of them not renewing, slim to none. Baltimore City is more than happy to sell us all the water that we need.
How does raising the water level affect the shoreline and the properties that directly meet the reservoir?
So what we're looking at is raising the water level by just over 2 feet. And there are easements on, I think they're called flowage easements, that are on all of the adjoining properties to address fluctuations in raising and lowering of the reservoir. So that would be within those easements.
Please describe the worst case scenario if the project is not undertaken and a major hurricane similar to Agnes strikes the area.
Sure.
What's the modeling of this scenario, and what would happen to Piney Run and Route 32? Sure.
So Hurricane Agnes was in 1972 and occurred while this project was while Piney Run Dam was being designed. And so Piney Run was built just a couple years later, and then was in place for Hurricane Eloise. Eloise, and I don't have all of the rainfall information at my fingertips, but depending on where you were in the county, Agnes was more, in Westminster, Agnes was more rainfall than Eloise. But I believe that in the Piney Run area, Eloise may have been a little bit more, but they were close. So, but similar orders of magnitude of storms. As I mentioned, Eloise, the water level in the reservoir came right up to the spillway, but did not go through it. So potentially Agnes, if the rainfall was a little bit more than Eloise, could have engaged the spillway and had flow, say hypothetically 6 inches, a foot deep, or so on. So there could have been flow through it. Jeff and his folks have not run through all the scenarios of those small storms to see what the erosion would be. Really the concern is that that extreme storm event, and you've got many feet of water flowing through it, and then the erosion of the spillway. So if the alternative 0 of no action were to be chosen, or if we were to have that hurricane between now and when we make these improvements, more than likely the dam would be fine, and that water would be would go through the spillway, and there might be some damage and so on. Part of our requirement for owning and operating a high hazard dam like this is that in the event of a significant storm like that, we have what's called an emergency action plan. And part of that emergency action plan is that we have one of our engineers is on site standing on the dam during those hurricanes. And we have had that. We have had someone out there during a hurricane monitoring the dam and making sure that everything is functioning as it's supposed to. The idea being that if you start observing issues that could compromise the integrity of the dam, there's an action plan that we have to follow that starts notifying people, people who live downstream, closing Maryland 32, and so on, to minimize that potential for that catastrophic issue. So that's a requirement as an owner and operator of a high hazard dam. So yes, if a hurricane were to strike and we have not made these modifications, could there be issues? Yes, but hopefully we would be doing everything in our power to minimize those sorts of dangers.
We have a couple more questions about the sediment. Mm-hmm. Folks are wanting to know if any of the sediment can be repurposed with the overflow spillway, in much the way that we use things like that for beach replenishment
Sure.
to help
Yeah.
reduce costs.
Yep. So what we have to look at is the consistency and the material that we're talking about. So as far as like raising the dam and so on, the consistency of that sediment is not something that we would want to use for doing dam construction. So that's where we're looking at balancing the site, where we would excavate from the spillway, the widening of the spillway, and take that material and put it on the dam. So minimize costs from that perspective. As far as repurposing the sediment, there is the potential, our bureau, my bureau, we do a lot of stormwater management facilities, and we have to excavate sediment out of some of those and so on. We quite often work with local farmers who are looking to level fields and looking for good nutrient-rich type material. And we'll work with them to supply that material. It gives us a place to take the sediment and other material we're excavating. So it's a cost benefit to us, and it benefits the local farmers. That's great when we're talking about a stormwater management facility where we're talking about maybe 50,000 cubic yards of material. In this case, we're talking about 1 million, 1.2 million. And just the sheer volume of sediment, yes, there's a potential we could work with folks and repurpose it in some locations, but it's just the sheer volume that we're talking about that is cost prohibitive.
Then, so to follow on to that, dropping it minimally to kind of get some of the sediment out to gain gallons, it wouldn't, given the cost benefit analysis, that based on what you're talking about, that's probably cost prohibitive. Even at a minimal.
Right. So let me grab a calculator here real quick. No, it doesn't seem right. Oh, I know why. Yes, so we're talking about inflows of sediment current today of somewhere on the order of 20 to 30,000 cubic yards per year. That type of sediment load would be manageable to repurpose and to address. But the cost associated with setting up, say, a dredging operation or any other sort of operation like that would be cost prohibitive. It's easy on a small site where you're doing a stormwater management retrofit. Setting something up at Piney Run Reservoir to reclaim sediment would be cost prohibitive.
Okay. Is there any thought given to addressing the issue so we don't have to worry about increased capacity in the future in terms of the sediment? You mentioned one tributary. Taking a look at that. That's already underway. Are there other things that could be done?
Yeah, so the reason why there's a sediment load coming in, I mean, there's always a sediment load in streams. So you never cut it off completely. And we basically put a dam across the stream. So it was expected that there would be a sediment load. There's always a sediment load. The quantity of sediment is based on the watershed hydrology and land use and so on. As it becomes more urbanized, you get flashier runoff and the streams start degrading and so on. So one thing that we do is more and improved stormwater management facilities. So essentially small reservoirs, small ponds that capture that sediment before it gets into the stream and then down into Piney Run, right? And so that's one option that we are always looking at. And then the other is stream restoration. So if you restore a stream so that you lay the banks back, give it the capacity it needs to, put it into a channel form that it wants to be in, and so you don't have these high eroded banks that are transporting all the sediment, that's another way of reducing the sediment load. So those are certainly options that we'll be looking at in the watershed to reduce that load that's coming down to the reservoir.
Okay. We're going to go back to our speakers. John Buck, welcome, and the floor is yours. Mr. Buck, are you there? He is still on mute. All right. We'll go and ask another question here. We'll come back to him. Oh, I see he's off mute. Mr. Buck? Hello? Hello, Mr. Buck? All right. Okay, we'll come back. And we have a question. If there is a water treatment plant planned, where do we have an idea where it would be located?
Yeah, so there was a study done several years ago, and Jeff, you probably know the date off the top of your head since you looked at this more recently than I have, that proposed a water treatment plant on the reservoir site right near the access road that comes down off of Hollandberry. If those of you are familiar with the Hollandberry Road, at the end of the road, there's a gate, and then that's the access road that runs down to the dam. So it would be adjacent to that road. That's where a potential water treatment plant could be. That's one potential location. There are other alternatives that our Department of Public Works have looked at. Another option would be to run a raw water line down to the Liberty plant and supplement water and treat it there. So there are all sorts of options. As I think I mentioned, those NRCS does not fund a study or analysis or design or construction of anything beyond pulling the raw water out of the reservoir. So water treatment plants and distribution lines and so on, they do not fund that. So that was not part of this study. So those are alternatives that DPW will evaluate. And if we go down this path, we'll have to figure out.
We have a question about the planned expansion for Freedom. Once that hits 5.4 million gallons of use, will Piney Run not be viewed as a potential expansion source?
I'm not quite sure I understand the question. So Liberty is the current source, and as I mentioned, current usage is just over 2 MGD. There's more capacity there. If development were to continue and increase to the point where we would top that out, then obviously other sources would need to be looked at. But we're talking very, very far into the future. I'm not quite sure I understand the question.
We have one other question about the water. If the water level rises 2.3 feet with alternative 2, what is the plan for flooding of roads? White Rock Road or White Rock sometimes floods during heavy rains.
Mm-hmm. Yes, so absolutely, that would be something that we would have to look at as far as what are the overall impacts to any modifications to the dam and the water levels. It may require doing some work on White Rock Road and raising it in that area. But those detailed kind of analyses and design considerations would be figured out in the next phase.
Go back to the
I'm sorry, I can't hear you, Kelly.
Oh, I'm sorry. I said we're going back to the folks who'd like to speak. So we'll go back to the lime coolers.
Okay, thank you. This is Sherry again. interesting on the last reply that was just given, it seems like the project, it keeps unspooling all these different things. Now we're talking about raising roads and doing this and doing that, which is going to continue to raise the costs that already we've determined can't be justified based on the lack of need. So going back to my last question, this cost keeps growing and we've already determined we don't have the need. So my next question is, there was a mention of the water depth near the dam being more than 54 feet or approximately, but what is the average depth of Piney Run Lake? My understanding is the average depth is significantly less, because it was noted in the alternate 2 option, the possibility of building a barrier and draining the lake down 30 feet. Well, it seems that would still leave the majority of the lake area completely devastated, turned into a mud flat and destroying all the habitats around it. So what is the average depth of the lake?
That off at the top of your head, Jeff?
Pardon?
Unfortunately, I do not have that information off the top of my head. I'd have to look, and that's something we could certainly, look in the information that we've prepared and get back to you. It's a good question, though.
Yeah. So I'm sorry, we don't know off the top of our heads what the average depth is, but you're absolutely right, is that in that hypothetical scenario where we could only drain down the reservoir by 30 feet, and we could maintain a 20-foot, say, sheet pile cofferdam or something along those lines. Absolutely, you're correct. The upper ends would be dry, but they would be dry temporarily during construction, and then they would be restored back.
I think that, but that temporary is undetermined, and any amount of time would be disastrous for the wildlife and the ecosystem and the habitats that depend on that. And, I don't have a lot of confidence that this time frame, that's at least the original time frame, would be, delays happen. It's inevitable that would be quite a bit longer than what is estimated.
Yeah, and so that's why we have to go through a permitting process, and we would work through with MDE, Wetlands and Waterways, with Department of Natural Resources, and so on, and obtain those permits, and they would look at all of those environmental impacts related to the project.
But again, I think that just another of many the reasons to not go with alternative to continue to stack one after the other. So I just don't see where there's any viable explanation why that would be a solution.
Could you also clarify your question about the study and the analysis that you posted in the Q&A?
Oh, that question is, so I think earlier, and I forget which one of you stated it, that in the event of the maximum flood condition, that the water would overflow the top of the dam. There would be more than 70 feet of water that would potentially be, I guess, flooding the area. The question, I read the report, and I read the Q&A that had been posted. And as you describe it, and as an engineer, right, I love calculations and love seeing analyses. I'm curious, there weren't any analyses or any assumptions that went into those analyses posted that said that you would actually overflow the dam. And with a 200-foot wide spillway with a 15-foot wall of water pouring through it continuously for 3 days, really makes me question if, what analysis was done, and what very broad assumptions were made to say that you would overflow the top of the dam. Mm-hmm. And can that information be made to the public or made available to the public?
Absolutely. I'll have to double check. I'm not sure. I'm not sure if we posted that or not, but yes.
Can I answer that?
Sure.
I think I can answer his question directly. So it's not that the dam would overtop by 70 feet. It would I think the gentleman who worked for the Corps of Engineers asked this question a little bit earlier, maybe a little bit differently. And during the PMF that we talked about, that worst case storm, the overtopping depth was estimated to be 3.5 feet over the crest of the dam. So the regular part of the dam, not the spillway, would obviously be deeper in the spillway. So 3.5 feet over the crest of the dam. And so the way that's done is using a hydrologic and hydraulic model. This particular model is required for use by the Natural Resources Conservation Service. It's called CITES. and there are sites outputs. And you said you're an engineer, so if you really want to get into the numbers in the report, it's in the back of the report, but it's also published in the text of the report. And I obviously cannot bring it up, right now, but the during that PMF under existing conditions or even an ultimate build out condition, which isn't much different than existing, we're looking at 3 to 4 feet over the dam. The height, the number 70 would be the total depth of water against the dam in such an event. So basically water like right up against the dam.
I still, and I did read the report, and referencing a model somewhere is not going to provide that analysis. I mean, the Piney, I think anyone that goes and looks on any kind of map and looks at the watershed for Piney Run, it's really small. It is not a large watershed.
Yeah, it's 10 square miles. It is not, relative to the size of the reservoir, it is not.
It is small, and then to tap it for a continuous source of water, all you got to do is look at the water coming out of the bottom of the dam, and you'd know if you start tapping that to the tune of a million gallons a day or 2 million gallons a day, that I would anticipate Piney Run as a creek would cease to exist.
Actually, we have a flow-by requirement of 1 MGD. And so if you go down to the discharge point of the reservoir where the principal spillway discharges, that never decreases below 1 MGD. So at the driest that you've seen it, it's still 1 MGD.
Right.
Into comparison.
That whole thing, then it would be gone.
No, so part of the appropriations and the permitting processes, we would still have that requirement of a 1 MGD flow by. And so we could not jeopardize. And so there's sufficient water and sufficient inflow for us to have that 1 MGD flow by and withdraw the appropriation amount. So I'm sorry, I just got an email with an answer to an earlier question. So did you have any other questions?
I did not.
No, I'm good for now. I mean, there's plenty of unanswered questions, but we can move on.
Okay, very good. So I just received an email from the Bureau Chief of Utilities and Department of Public Works. The question was asked what the contract with Baltimore City, and what he indicated is that we have just recently updated that agreement, an extension of the water purchase for a 3-year period and a possible extension for a 4th year. So that has, so the question as to the timing of the contract negotiations or whatever with Baltimore City, that has been established for the next 3 years with a possible 4th year.
To get Mr. Buck back on the phone or on the line. Mr. Buck, if you would like to ask a question, we'd love to hear from you. Mr. Buck, we see I see you're off mute, but we can't hear you.
I guess if there are technical difficulties, he could always text the question into the Q&A.
Yes. There is a question in the Q&A, speaking of which. Back in 2011, in the summer, the water level was lowered. Do you recall, Chris, why that was done and by how much?
Oh goodness, no, not off. I'm sorry, off the top of my head, I do not know why the water level was lowered. I mean, I can certainly look into it and post that in the answers to the Q&A.
Okay. Great. We have about 10 minutes left, and we've gotten through all of our questions. And we are happy to answer additional questions in the next 10 minutes. Anybody has anything. As Chris mentioned, we are going to be putting the Q&A document together. And that will be posted on the website. If you have any other questions or comments, or again, things that you'd like to hear about before the commissioners convene, and things that you want to share directly with them, either the Piney Run study at carrollcountymaryland.gov is an email you can use, or you can go to the website and there is a green button on the right-hand side. It says click here to email comments or questions. You can use that.
And
I am going to go. Oh, go ahead, Chris.
I was just going to say, I'd also note that since the attendees registered for this meeting, we have your email addresses, and we can send out emails. We'll put you on the email list for information about as this project progresses, so you can stay informed as to what's going on.
Of emails. And while we have a few minutes left, I will ask folks, what is their preferred method? If you could pop it into the Q&A box, your preferred method of reaching you about these meetings. Email, social media, newspaper, advertisements, or articles, things like that. That would be helpful to know. Because we do want people to be involved. It's an open, transparent process. We want to give as many questions and answers as we can. So we want to make sure we're reaching you. So as you continue to type that in, I see, well, I thought we had somebody with their hand raised, but I do have one person on the phone, and I want to give them an opportunity to ask any questions as we are here. Someone with the phone number ending in 3899. If you'd like to unmute your line, we'd love to hear from you. I think they hung up. So
I think some additional questions came in the Q&A.
Oh, those are some ways that folks like to.
Okay.
The consensus is email. So again, if anybody has anything else they'd like to ask, we are here and willing for the next 6 minutes.
All right, well, not hearing or seeing any other questions. Want to thank everybody. This was a great discussion, very much appreciated. Lots of great questions and great information. I hope you all gained a lot from this. We will keep you in touch as far as this process progresses. Feel free to ask questions through the email address and so on, and we will respond to those, and we will be conveying all this information to the county commissioners so that they can make their decision. With that, I think we can adjourn the meeting. Thank you all.
Thanks, everyone.